Hi everyone, welcome back, and here's that example 3.3 again that I worked partially earlier. Now this time we're going to see all the numbers and we're going to make sure we go through every single step to figuring out the resultant from four forces. Now at this point you should really avoid the parallelogram method. It is still possible to solve, it is just painful. Okay, it's just painful. Now, if you have an amazing graphing calculator, or if you're like using SOLIDWORKS or something, then sure, the parallelogram method can be amazing. But let's not worry about that right now. So to get us started off, I need to break all these into components. So I'll start with F1 and F2. I'll do this by hand, we'll check myself. So first off, I draw two triangles. Okay, well I've got F1 like this. That's 8. This is 25 degrees, that's my right angle. And this will be F1y, that will be F1x. Well, F1x is adjacent over hypotenuse, which is cosine of theta. So cosine of 25 degrees is equal to F1x over 8. Great. F1y is opposite over hypotenuse. Opposite over hypotenuse is sine of theta. So sine of 25 is equal to F1y over 8. And both of those are positive because it's pointing up and to the right. As a note, your trig functions just give the ratio. If you had a slope triangle, you'd have that ratio. Your trig functions, they're just popping it out. So that's why we can do the exact same thing as we did earlier. Now let's do F2. And I've got arrow pointing down. Okay, draw it over, draw it down, right angle here. And this is 30 degrees. Good. I know that this is 12. And now let's name everything. So this is F2x, that's F2y. What I get is that adjacent over hypotenuse, that's cosine of 30. So cosine of 30 would be equal to adjacent over hypotenuse, which is F2x over 12. And I would get that opposite over hypotenuse is equal to sine of 30. So I'll move it over here. Sine of 30 is equal to F2y over 12. Now let's check myself and see how I did. So looking at this, F1 cosine of theta is equal to F1x. We're good. So that's 7.25 kips. F1y is F1 sine of theta, which we got right. 3.38 kips, good. F2x is F2 cosine of theta. We got it right, so 10.39 kips. And F2y is F2 sine of theta, and the only thing I forgot was to make sure that there was a negative sign at the end. There you go. Now this will be negative 6 kips. If you know what a kip is, it's a kilopound, it's 1,000 pounds. That's a kip. Okay. So let's repeat that process now for F3 and F4. We did it once, we can do it again. I believe in us. So I'll start with F3 because I want to try to go in the same order as the numbers. So draw my arrow down, draw it over, and then down again. Perfect. Ugh. And what do I get? Well, I get F3y, I get F3x. It's all named. I put my angle in, so this would be 60 degrees, and this would be 10. So now I do exactly what I did beforehand. Well, adjacent over hypotenuse is F3x over 10. And adjacent over hypotenuse is cosine of theta. So it'd be cosine of 60. I can solve that. Opposite over hypotenuse, well that's F3y over 10. And opposite over hypotenuse, well that is going to be equal to sine of 60. And all that's good. So I've got those two components and I can solve them fairly simply. Just plug them in my calculator. Be very careful that you're in degrees mode if you're using 60. Okay? If you're in radians mode, you will get a completely wrong answer and you probably won't even realize it. Now let's do F4. So I draw my force triangle. Okay? And one thing I did forget is that F3y and F3x would have been negative in the end. Let's add a little negative sign here. Just make sure I remember that. Because they're pointing down and to the left. So I've got F4x, f4y. This is 5 kips, and this is an angle 50 degrees. So adjacent over hypotenuse, well, that's f4x, and it's negative because it's going to the left, over 5. And that would be equal to adjacent over hypotenuse, which is cosine of 50. And then f4y over 5, which is opposite over hypotenuse, is going to be, okay, that's f4y over 5. And what is opposite over hypotenuse? Well, that is going to be equal to sine of 50. And so I can then solve. f4y is positive because it's pointing up. So let's check my numbers again and see how I did. I'm going to erase this now because it's kind of in the way. Okay, so f3x is f3 cosine of theta, and it's negative. So negative 10 cosine 60, we got that right. f3y is negative because it's pointing down. And it's sine of theta, and we did sine of theta, so we got that right. Negative 8.66 kips. f4x is times cosine of theta, so that's what we did, got it right. And f4y, once again, we got that right too. So, we got all the steps right so far, so we have it all in their components, and we have all the x components, we have all the y components, and we need to add them together to get our resultant. So let's go ahead and do that. I won't bother writing it out. I'm just adding together all of the x components. I add together all the y components to get my overall vector, which looks something like this. So I have 9.43 in one direction, and I have negative 7.45 in the other. Okay, draw my angle right there. So I need to figure out what this angle theta is. Now I need to find out what r is. How do I find r? I use Pythagorean theorem. This is a right triangle. Everything comes back to right triangles at some point. So I know that a squared plus b squared is equal to c squared, or that c is equal to the square root of a squared plus b squared. And I have it. It's beautiful. So let's plug it in. I get it correct. Wonderful. And I need to find the angle, which, well, if the angle is theta x, there's lots of ways of getting it. Especially since I know the resultant now. I just pick any two sides and I use that trig function. So I'm going to choose the opposite side and the adjacent side, which is 7.45 over 9.43. Okay, so opposite over adjacent is equal to what? Well, that's tan of theta. So if I take the inverse tan of my ratio right here, I get that theta is 38.3 degrees. And I'm done. I've solved the problem. So, thanks for paying attention, thanks for listening, and I'll see you all next time. Bye-bye.